All right, let's talk about that piece of paper that comes with your balance, the calibration certificate. You know, the one that usually gets filed away and completely forgotten about? Well, it turns out that document is holding a secret. It's basically a treasure map. And today we're going to learn how to read it to find the true weight of your samples. This is going to be fun. So picture this. You're in the lab, you put your sample on a super precise analytical balance, and this number pops up, 200.000. I mean, that looks perfect, right? It feels so exact. But here's the million-dollar question. Is that number staring back at you? The real, absolute, true weight? The short answer? Nope. Almost certainly not. And that tiny difference? Well, it can matter. A lot. And here's why. Every single precision instrument, I don't care how expensive or fancy it is, has a tiny, predictable error. It's just a fact of life. That beautiful number on the screen is an amazing estimate, but it's not the whole truth. You could almost say the balance is telling you a very consistent, very small, little white lie. So if the screen isn't telling us the absolute truth, how do we find it? Well, that's where this comes in, your calibration certificate. Now, I know, it looks boring. It looks like just another piece of paper for your compliance binder. But it's not. It is your official decoder ring. Seriously, think of it as a personalized performance map for your specific balance. And once you learn how to read this map, you can go from just seeing a weight to truly knowing a weight. And that, right there, is the difference between doing good work and doing exceptionally accurate work. Okay, so how is this map even made? Well, it all boils down to the results from 3 really important tests. Once you get these 3, the whole certificate just clicks into place. First up, and this is the big one for us today, is accuracy. It's a really simple idea. If a technician puts a perfect certified 100-gram weight on the balance, how close does the screen actually get to reading 100.000? That little bit of difference, that's the error. And here we can see the actual results from that test. Just look at the line for 200 grams. They put a 200-gram test weight on there, but the balance only read 196.028. So that's an error of negative 3.972 grams. It's consistently reading low. But here's the beautiful part. The certificate gives us the fix. The correction factor is just the opposite of the error. It's the exact number we need to add back to get to the truth. Simple, right? Okay, test number 2 is called eccentricity. It's a fancy word for a simple question. Doesn't matter where on the weighing pan you put your sample. I mean, if you put it in the dead center versus way off on the corner, do you get the same number? This test basically checks if the balance is leveled correctly and if the mechanics are all aligned. And for this particular balance, the result is awesome. A maximum error of 0. That tells us it's perfectly leveled, mechanically sound. It's a huge green light. No problems here. And the third and final test is repeatability. This one is all about consistency. If you weigh the same thing, say 5 times in a row, putting it on, taking it off, putting it back on, do you get the exact same reading every single time? And once again, this balance is an absolute champ, a standard deviation of 0. It hits the exact same number every time. So let's recap. We've confirmed our balance is perfectly aligned and incredibly consistent, but we also know it's consistently inaccurate. And now, thanks to that certificate, we know exactly how to fix it. All right, this is where it all comes together. We've cracked the code on the tests. Now let's actually use that correction factor to turn the number on the screen into the real-world true value. Probably the easiest way to think about this is like having a watch that you know is always 2 minutes fast. You don't get rid of the watch, right? You just glance at it and automatically subtract 2 minutes in your head. Well, the correction factor is exactly the same thing for your balance. It's your automatic built-in adjustment to get to the right answer. And using it is so simple. It's just 3 steps. First, weigh your stuff, write down the number. Second, grab your certificate and find the test weight that's closest to what you just weighed. Third, find the correction factor for that weight and just add it to your number. That's it, you're done. Let's walk through a quick example. Let's say your balance reads a perfect 100,000 grams. Okay, we go to our certificate, we find the line for the 100-gram test weight, and we see the correction value is plus 1.986 grams. We just add them together. And boom, your observed value of 100 grams is actually a corrected true value of 101.986 grams. You've just taken a reading and made it real. Okay, so that's the simple method. And for most things, it's great.
But what if you need to be even more precise? What if close enough just isn't in your vocabulary? Well then, my friend, it's time to level up and talk about interpolation.
So the obvious question that comes up is, well, the certificate has data points for 100 grams and 200 grams. But what if my sample weighs 120 grams? It's right in the middle. Which correction factor do I use? The one for 100? The one for 200? The real answer is neither. For ultimate precision, we calculate a brand new one, just for 120 grams.
And we do that with a technique called linear interpolation. Now, whoa, hold on, I see a formula on the screen, don't get scared. It looks way more complicated than it is. All this thing is saying is that we assume the error changes in a nice straight line between our two test points. This formula is just the recipe to find any point along that line. Let's just plug in the numbers for our 20-gram sample. W1 is our lower known point, 100 grams, and C1 is its correction. W2 is our higher known point, 200 grams, and C2 is its correction. And W is just the weight we're interested in, 120. See? We have all the pieces.
And when you run those numbers through the recipe, it spits out a brand new, custom-made correction factor just for us, plus 2.383 grams. So our observed weight of 120 plus our new correction gives us a true weight of 122.383 grams. Now that is next-level precision, pulled right from the certificate. So now you have this amazing new skill. The big question is, when do you actually need to use it? I mean, do you have to do this for every single thing you weigh? Let's talk practical application. Okay, here's a pretty good rule of thumb. For really small amounts, say under 20 grams, the error is usually so tiny that you probably don't need to worry about it for most day-to-day stuff. But once you get into that heavier range, especially from 20 up to 200 grams, if you're doing anything where high accuracy is critical, you absolutely should apply the correction. And just be careful if you're weighing something way below the tested range, because the balance might behave differently down there. And there you have it. You've got the decoder ring. You know how to read the map. You know how to take that number on the screen and turn it into something much, much closer to the truth. We just decoded this certificate together, so the only question I have for you is, what does yours say?